Okay, I want to take an opportunity to introduce you to the test data that you're receiving here. Talk to you a little bit about why we selected the tests that we selected and what those tests actually mean. And to guess at the most fundamental level here, we selected tests that measure what's called ground reaction forces, or the way that you interact with the ground from a force production standpoint. So the harder you push into the ground, the greater your flight time, the more torque you're able to generate, the greater your ability to accelerate, run fast, jump high, walk efficiently, all of those types of things, run efficiently. So all of those things are predicated on ground reaction forces. And when it comes to ground reaction forces, we've really kind of surfed the continuum of those forces. So the slowest and opportunity for the greatest amount of force production is our isometric mid-thigh pull, or the IMTP. You want to think about this IMTP like building an engine in your car. It's really how much force can you produce irrespective of time. Okay. The second test, the static jump, takes that to another level. We want to know how much force you can produce without using like a preloading or elastic effect, just simply force production, but now under time constraints. So that's going to be kind of the direction of your static jump. And then your counter movement jump is going to involve this elastic nature where you have the ability to descend, store energy, and then explode up off the ground. And think of that in your car like the springs in your car. So you have sort of this continuum of peak force to force restricted over time. And then you have the ability to produce this force using not just a singular upward contraction, but the ability to preload. And all of these characteristics, ground reaction forces, they're kind of like wood in a house. They're raw materials. You can take these materials and apply them across any sport. So if you take and use that the same example from building a home, we want to take our 2x4s, and those 2x4s can be used to build the insides of the wall. They can be used to build the roof, the roof line. And when you finish the house, just because you used the wood doesn't really dictate the design of the house. Again, it's a raw material, so it can be applied to many different designs of homes, just like the ability to produce force and produce force quick can be applied to a myriad of different athletic endeavors, including all of the sports that we offer here at the college. So hopefully that kind of explains the continuum of tests, why we selected those tests, and what those tests really mean for you as an athlete. But without going in too much deeper into that, I would like to spend a few minutes here discussing your specific results. And I've pulled up just kind of an aggregate of data here. But when you receive your results, you're going to see this summary. You're going to see your name. You're going to see your sport. Okay. The test date's going to show all the dates. This section here, the last 28 days, this is your most current test. Okay. So this is where you want to kind of start. The first one is your IMTP peak force. So this is really, again, the size of your engine. How big is your engine? How many horsepower do you produce? So this is your peak force number. Relative peak force is kind of like the pound per pound amount of force that you produce. So in this case, 38.68 newtons per kilo. And again, this is kind of like a fighting weight, a pound per pound amount of force. The next column here, and two numbers that we'll get into, is actually how high you get off the ground. So in the static jump, you would look at this as 36.23 centimeters, okay? And then in the counter movement jump, you have a jump height of 41.03 centimeters. So again, displacement off the ground, force production respective of time, and then force production respective of time with the added element of the ability to use elastic energy or springs. Okay. The next column here is two comparative metrics. So the first metric here is eccentric utilization ratio. That is a comparative metric between the static jump height and the counter movement jump height. We want this number to be ideally between 8 and 13. Numbers above 13 indicate that we need development of our engine. So we need more raw material in terms of peak force. Okay, on numbers below 8% would dictate that we need work on our springs. Okay, so we need more velocity, more elastic energy work. And numbers between 8 and 13 mean that those two traits can be developed simultaneously. So that's great. The next one is dynamic strength index. That's going to be a comparative metric between this counter movement jump height and your isometric mid thigh pull. The ideal number here is going to be between 60 and 80%. Again, numbers above 80% are going to dictate that you need work on your engine. Okay, so you need to improve your force production. Then numbers below 60% mean that we need work on our elasticity and our bounce. So you're going to see more effort on the springs. So what does that mean for you specifically? Well, if this number is above 13 and this number is above 80, we need to be really conscious of selecting appropriate load. So we need to really be driving load home and really pushing weight here so that we can improve our overall ability to be stronger. Now, if these numbers are below 8 and below 60, we need to make sure that we're really putting a tremendous amount of emphasis on moving as fast as we can. Okay, so while many of our lifts are always executed as fast as we can, we really need to make sure that we don't waste repetitions here by moving slowly. Okay, so that's kind of the direction of each of these tests. On the right here, you can see your body weight. This is your average body weight over the test date selected. So you can kind of see where you've been over the course of time. And then you can see longitudinal trends here in this next section, which is entitled Force Profile. So you can see each one of these is a measure of your raw material or the engine. So these engine metrics over time, you can see in this case, have improved over time. And we would like to see that obviously continue as we go, under the caveat that understanding that there are times of the year when, yes, that will decline because you're either competing hard or training hard. And when you're competing hard and training hard, then sometimes those numbers can decline. And in a lot of cases, we would like for them to decline because there is a significant amount of stress on the body. So that is totally normal and in a lot of cases very desirable. On the bottom part here, this is your power profile. And this is really going to be a measure of your ability to use your springs. So force applied to the ground, but now under a time constraint. Okay, so you can see again longitudinally over time where that would take you. And once again, we would like to see these numbers improve over time under the caveat that these numbers are even more sensitive to fatigue. And if we're really training hard, that these numbers may decline, and in some cases, it's desirable for them to decline. Okay, and you can also see here your velocity numbers, and velocity is causative to jump height. So the faster we're moving at takeoff, the higher we're able to jump. So that's why we're constantly harping on you to be moving as fast as you can possibly move when instructed to do so. And this final section here is scaled. So if you can think of this as a normalization of the data for body weight. So this allows you to compare you over time, assuming that all body weights are equal. So you can see that for your given body weight, this person scored 280 points, then 292, then 296. What that means is on the IMTP, we are getting more out of your body, normalizing, once again, normalizing for body weight. You can see the same thing for counter movement jump, 297 to 296 to 302. And so you can see this is sort of a wave effect where in this case, we got a little bit less out of the body and then now kind of a little bit more. And now on the static jump, you can see that this number is accumulated over time. So we are continuing to get more out of this person's body for what their body size is. As their body changes, we obviously take and make all those numbers relative to each other and normalize that data. You can see, think of this as a point system. How many points do you score? The closer you creep up to 1,000 or beyond 1,000, think of that as a better athlete that you are. Okay. I think that an ideal, there is no real ideal number here, but we would like to see the total accumulate over time. So, all right. So if you do have questions about this data, as you continue to explore your own situation, explore your own data, and really make your own training decisions, please feel free to reach out to myself or one of the other coaches, and we'll definitely help answer any questions that you have. And appreciate you listening to this, and let me know if you have questions. Thanks.